The Finnegan TSQ Quantum is the most powerful and advanced triple quad available in the world today. There's one feature that really stands out, and that would be HSRM, highly selective reaction monitoring. What would happen if you had a co-elutor with the same parent mass and the same product ion? You'd get a false positive. Now what if that parent ion had a mass difference of, let's say, more than 0.1? With HSRM, we select it out in Q1. It is no longer a problem. It's better. It's much more selective. It guards against false positives. It eliminates them. What chromatography cannot do, HSRM can. The TSQ Quantum features the revolutionary IonMax source. The IonMax source we spray off-axis. This improves robustness. We never block the source. We do not have carryover in the IonMax source. We have a very large drain. The spray goes in the source and it goes out of the source. The ESI probe and the APCI probe are interchangeable. You just pull out one probe, and in about 30 seconds you could put in an APCI probe. You can also add, if you'd like, an APPI probe with the APCI probe. It's a combination probe. So you can have the UV light shining at the same time that you have the APCI corona discharge. This can be particularly important with difficult to ionize compounds like PAHs or even steroids. To increase ion transmission and focusing of the ion beam into the mass analyzer, we've increased the volume of our ion transfer tube. If one wants to replace the ion transfer tube, you can relatively easily with the tool supplied with the instrument. All this can be done without breaking vacuum. You are up and running in about 1 minute. The Finnegan TSQ Quantum is the only triple quad in the world to employ hyperbolic quads.
The hyperquad is a trade name for pure hyperbolic quadrupoles. The equations of motion for ions in a quadrupole field assume that you have a quadrupole rod structure. The correct answer is to use pure hyperbolic fields generated by hyperbolic poles. The reason most people don't do that is that it's very technically difficult to create hyperbolic poles. The round rods are an approximation. The fourfold symmetry is correct, and the ratio of the diameter of the rod to the spacing between the rod is chosen to try to minimize selected field faults. There is a debate amongst the scientific community, and probably each vendor has their own opinion about what the right combination is, but you cannot drive all of the non-hyperbolic field contributions to zero if you're using round rods. If you're using hyperbolic rods, you can have a quadrupole field component and have all other field contributions zero. That's the right answer. That's what all the math is expecting. And the resolution and performance we get is because we are building a device that is consistent with the theory. We have a bent collision cell for two reasons. The most obvious is it allows us to take a long mass analyzer and put it on a bench by folding it in the middle. And second, it breaks the line of sight from the ion source to the detector. Ions can be neutralized in the transfer optics in the source region, and if they don't have a line of sight, they can't make it to the detector region, so it reduces our background noise levels.
The Finnegan TSQ Quantum. It's more selective, it's more specific, it's better.